Today we're going to spend some time looking at how to convert measurements. So you should have a copy of a paper that looks a little like this. We're going to start by writing our learning target at the top of today's paper. And it says, I can use ratios to convert measurements. And the title of today's page is measurement conversions. We're just going to jump right in. So the first example, before we start, let me just tell you that any of these, there are some measurement conversions that you should commit to memory. Basic customary measurements and all metric measurements you should commit to memory. If you don't already have those memorized, there are a lot of really good games online that you can search out, and you can also use the cheat sheet that you got today in class. So we're just going to talk through some examples today. The first one says, your mom is making cookies. The recipe calls for 3 tablespoons. Notice this says 3 tablespoons of baking powder to make one recipe. And your mom is going to make 6 batches of cookies. She can't find her tablespoon measuring spoon, but knows that 1 tablespoon is the same thing as 3 teaspoons. How many teaspoons, so this is what we're trying to determine, of baking powder will she need? So the first thing that I think of when I hear this question is she needs 3 tablespoons for 1 batch of cookies, but she's going to make 6 batches of cookies. So that means she's going to need a total of 18 tablespoons of baking powder to do all of those cookies. So we're going to use what we call a ratio table to solve this problem. So we're going to make a table that's going to represent the 2 things that we're comparing here. Now remember, a ratio is just a comparison of 2 numbers. So we're going to compare tablespoons and teaspoons. And in the question, it tells us that 1 tablespoon is the same thing as 3 teaspoons. So if I had 2 tablespoons, that means that I doubled this, so that means I also have to double this. It's just a matter of comparison of numbers. So this one would be 6. And if I then doubled this, that would be 4, and then this would give me 12. So I hope that you see how this works. But I want to get to 18 tablespoons. Now I could continue this 1, 2, 3, 4, 5, 6, 7, 8 all the way out. Or I could just think about connections between numbers because I'm trying to get to 18 tablespoons. 4 won't help me, but I can get there from this 2. So how can I jump from 2 to 18, you ask yourself, and that would be times 9. So 6 times 9, because that's the equivalent ratio that we're trying to build, would be 54. So based on that computation, Mom would need 54, and these are teaspoons of baking powder to be able to complete those 6 batches of cookies. We're going to talk through several other examples. That's a ratio table. For number 2, we're going to solve it just using a ratio. It says Tatiana needs 4.5 feet of fabric to make a new dress. The fabric store sells fabric in yards. Okay, so here becomes our problem. She needs 4.5 feet of fabric, but when she goes into the store, they sell them in yards. And so she can't exactly just say, hey, I need 4.5 feet of fabric. So we are going to compare feet and yards. And we're going to just set up a little ratio table that looks something like this. Now, I know the comparison between feet and yards, and you should too. You should know that there are 3 feet in every 1 yard. So the first thing that I put into my table is 3 feet and 1 yard. Then I go back to my problem and it says she has 4.5 feet. Now you could write 4.5, or you could write 4.5. We all know that. And then this becomes a ratio comparison, and I'm trying to figure out how many yards of fabric. Here's my question. How many yards of fabric will she need to purchase? So this one's not as easy because I can't exactly jump from 3 to 4.5. So I can use something that we've been working on called cross products or cross multiplication to be able to help me solve this particular problem. So that means I'm going to multiply 1 times 4.5. And we all know that if I do 1 times 4.5, that's just going to give me 4.5. And then I'm going to divide that by 3. So you'll see me put it in on my calculator. I'm going to do 4.5 just because that's faster for me to put in on my calculator. I'm going to divide that by 3. And you see that it says that she needs 1.5, which is the same thing as 1 1/2. So she's going to need 1 1/2 yards of fabric in order to complete her dress. So you see how those are very similar. It's just that we tackled this one a different way because we didn't have a direct multiplicative relationship. Let's go on to number 3. It says an inchworm can crawl an average of 1 mile in his life. Tiny little inchworm can go a whole mile in his entire life. How many inches can he crawl in 1/4 of his life? And sometimes you're going to see a problem and they'll tell you the conversion factor, which means they give you the ratio comparison that you need. So we're going to use a tool called a double number line to solve this one. So we're going to draw a picture that represents that little inchworm's life. So this would be the beginning of his life, and then this would be the end of his life. And the problem tells us that in his entire life, he can crawl 1 whole mile. And so this, of course, would be 0 because that's the beginning of his life. He's not gone anywhere. And then in the problem, they tell me that 1 mile is the same thing as 63,360 inches. So you see how I labeled that on the inch line, and I put 1 up here on the miles line. Now we're trying to figure out how far he can go in 1/4 of his life. Now remember, this picture represents his entire life. So if I'm trying to get to 1/4 of his life, I'm going to use what I know about numbers. I'm going to do this. So that takes me to, you might have guessed, 1/2 of his life. Well, if that's half of his life, then all of these numbers are going to be split in half. For example, this will be 1/2 of a mile. And I can do 63,360 divided in half, or divided into 2 parts. And that gives me 31,680 inches. But that's still not my answer because that's half of this little inchworm's life. We're trying to get to 1/4 of his life. If you know anything about numbers, you know that I can take 1/2 and I can split it in half again, and that gets me to 1/4 of that little inchworm's life. So now that I know this, I know that this is going to be 1/4 of a mile, and I can determine what this number is right here because all I have to do is 31,680 divided in half again, because that's what I did, and that gives me 15,840. And that's inches. So the answer for this one is 15,840 inches. Now, some of you may be thinking that there is a different way that you could have done this, and yes, there is. I just wanted to show you that double number line. You could have very easily have just taken this and divided it into 4 parts, and that would have given you the same answer. Example number 4 says the longest singular base jump glide, that's where people jump off of a stationary item and they glide down to a lower area, is recorded as 15,840 feet. Then the question says, how many miles would this be? So I have to know some stuff here. I have to know that 1 mile is equal to, and I hope you know this, 5,280 feet. If not, that's a very good one to memorize because that's one that you will use for years to come. So we're going to use 2 equivalent ratios to see if we can figure out what the answer for this one is. So we're comparing feet and miles. So I'm going to put 5,280 feet is the same thing as 1 mile. So I'm just setting up a ratio comparison. And then I'm going to set up an equivalent ratio comparison, and I'm going to put 15,840 feet You probably guessed it right here in the top, because that's the part of my ratio that represents feet, and we're trying to figure out how many miles is that. So now we're going to use a little bit of cross comparison to see if we can find this answer. So I would start by doing this, 15,840 times 1, which we all know is just 15,840. And then I'm going to divide that number by 5,280. So I'll show you what that looks like. 15,840 divided by 5,280. And you see that that gives me an answer of 3. So then all I have to do is plug that back in here, and you see that it gives me my answer. My answer is 3 miles. Easy enough. Okay, let's go on to example number 5. It says if 1 inch, so 1 inch is equal to 2.54 centimeters. So they're telling me this. 1 inch is equal to 2.54 centimeters. How many centimeters, so this is what we're trying to figure out, how many centimeters are in 3 inches? So again, we're going to use a ratio comparison. They told us that 1 inch is the same thing as 2.54 centimeters. And it really doesn't matter which one you put on top and which one you put on bottom, because it is a ratio comparison. And you're just going to plug in the identical unit on the other side of your equivalent ratio. So if I'm looking for an equivalent ratio here, these are inches, so that means the 3 inches has to go here. And remember, we're trying to figure out how many centimeters, so that question is right there. Now I'm going to argue that this one is a pretty easy one, because I know that I can get from 1 to 3 multiplicative relationship by doing times 3. So that means to get my answer here, all I have to do is multiply times 3. So 2.54 times 3 gives me an answer of 7.62. And my answer is centimeters. Remember, it says how many centimeters. So it's 7.62 centimeters. And then one final question says if 1 foot is equal to 0.030, so 30/100ths of a meter, how many feet, so this is what we're trying to answer, how many feet does a track athlete run if he runs the 150-meter dash? So we're going to set up another little ratio box, a ratio comparison. And what we're looking at here is the comparison between feet and meters. So you see how they gave me that. Now you'll notice in a lot of word problems, if it's an uncommon conversion, they'll give it to you. Like we didn't know that 1 inch is equal to 2.54 centimeters. That's not one that a lot of people memorize. Most people don't memorize the comparison between feet and meters. These up here, these customary conversions, they expect you to know. So make sure that you memorize those that are easier. In this problem, they did tell us that 1 foot is the same thing as 0.30 meters. And of course, you could always leave off that end 0 if you wanted to. It's just a placeholder. And we want to know how many feet. So I'm going to put a question mark right here because that's what they're asking me. How many feet? So that question would go there. Does a track athlete run if he runs the 150-meter dash? So this is what we're trying to figure out. And some of you may be math-minded enough that you could recognize this connection, but we're going to use that cross-product method again. So we're going to do 150 times 1, and we've been lucky. All of ours have been times 1, but it won't always be that way. So that gives me 150. And then we're going to divide that by our missing number here, which is 0.30. And I'll show you what this looks like, just so you know how easy it is. Notice I left out that beginning 0. I could go in and put it back in. For those of you who are sticklers for details, you're going to get the same answer either way. And you see that it gives me an answer of 500. So I'm going to write this right here just so I know what my answer is. And it says how many feet, and of course that goes in the feet blank. So that athlete is running a total of 500 feet if he runs the 150-meter dash on the track team.